Hello, everyone. The following is the presentation of our CVPR 2023 paper, Crowd3D, Towards Hundreds of People Reconstruction from a Single Image. We propose Crowd3D, the first framework to reconstruct the 3D poses, shapes, and locations of hundreds of people with global consistency from a single large scene image. The reconstructed people are in a unified global camera system and have precise 3D spatial locations. Our main contributions include: first, we design an adaptive human-centric cropping scheme and a joint local and global strategy to achieve the globally consistent reconstruction. Second, we propose a progressive reconstruction network with a newly defined HVIP to alleviate the depth ambiguity and obtain global reconstructions in harmony with the scene. Third, we contribute Large Crowd, a benchmark dataset with over 100K labeled crowded people in 733 gigapixel large scene images. To infer the accurate 3D locations of people, we define a new concept, HVIP, abbreviated from Human Scene Virtual Interaction Point, which is the projection point of a person's 3D torso center on the ground plane in the global camera space. This definition establishes a mapping between local image points and global spatial positions of people, alleviating the depth ambiguity. Specifically, HVIP is a point on the ground plane, allowing us to connect 2D pixels with 3D points on the ground plane through the ground transformation. HVIP is bound to the human torso center by the vertical relationship, thus the 3D torso center position of the human can be accurately inferred with the perspective projection constraints. Our method consists of three main steps. We use an adaptive human-centric cropping scheme to crop the large scene image into patches with hierarchical sizes, which ensures the appropriate human height ratio among cropped images. Inspired by the observation that human heights hierarchically vary like a pyramid in the vertical direction of large scene image, the sizes of the cropped images should also conform to a similar hierarchical change. Heuristically, we use a geometric sequence to simulate the hierarchical change. We set the height of people in a block to be half of the block size and give the cropped parameters. The partition problem is converted into a search problem. We estimate the camera intrinsics and equation of the ground plane of the scene with human pose priors for subsequent inference. In this step, we only use the standing or walking people who can be regarded as vertical lines on the ground plane. And we assume the ankle joints of these standing people are on the ground plane. The estimation does not need too many people, more than 10 standing people are enough. We use the following optimization losses to solve the camera and ground parameters iteratively. Taking the cropped images, ground plane, and camera parameters as inputs, we designed the Crowd3D net with the progressive position transform based on HVIP to directly estimate the human meshes in the large scene camera coordinate system. We also contribute Large Crowd, a dataset with over 100,000 labeled humans with 2D bounding boxes, 2D key points, 3D ground plane, and HVIP labels in 733 gigapixel images of 9 different scenes. We show the qualitative comparison results on Large Crowd, with 2 baselines with large suffix in their names, representing that they are modified from the state-of-the-art methods, as no existing methods can directly handle large scene images with hundreds of people. The horizontal view shows that our results are coherent with the ground plane while the compared methods are not. The bird's-eye view shows that our method reconstructs consistent results while the compared methods do not. Specifically, for several people in a linear arrangement, only our results consistently keep this arrangement in 3D space. Here is another example. Our method also reconstructs the most reasonable results in all views. On the public large scene dataset Panda, with different and unknown camera parameters, our method reconstructs reasonable and consistent results as well. Thanks for watching, and you can scan the barcode to check the project page with more info.